On page 114, question number 3, we'll do 3F, 3J, and 3T. On question 4, we'll do part number A. 5, we'll do 6C. On number 7, we'll do 7B, and we'll also do number 8. So getting started on the first problem, we have to 3F, we have to solve for x. We have the product of x squared plus this term which is in brackets. So if the product of these two is 0, one thing we can say is that first of all, the first term x squared can equal 0, and so one of the possibilities is that x is 0, because if this is 0, then 0 squared is 0, and 0 times whatever is in this bracket is also 0. So one of the solutions is 0. The other thing is if this whole term here is equal to 0. So what is contained within the square brackets is equal to 0. So if that's the case, we transpose the minus 5 from the left to the right. And now if we do that, and then we put the 9 on the denominator, we get x plus 4 squared equals 5/9. In other words, we're dividing the left side by 9 and the right side by 9. So we just have x alone. Now we take the square root of x plus 4 squared, and we get this. We take the square root of this, we get plus or minus our root of 5 over 9, and the root of 9 is 3. So this is a perfect square. So and when we transpose this over here, it becomes minus 4. So we get minus 4 plus or minus the root of 5 over 3. Now we'll check this answer right here, and we'll put it into the 9x plus 4 squared minus 5. And we get that equal to 9, and we replace the x with minus 4 plus root 5 over 3. So that's right here. So this x here is replaced by these two terms. And this plus 4 here is this plus 4 here. And what happens is the plus 4 and the minus 4 sum to 0. And when we square root 5 over 3, we get 5/9. Root 5 times root 5 is 5, and 3 times 3 is 9. So again, the minus 4 and the plus 4 sum to 0. This squared gives us this. The 9's cancel, and I have 5 minus 5 equals 0. If I do the same thing over here with a minus 5 root 3 minus root 5 over 3 instead of the plus, the only difference is we still have the minus 4 and we still have the plus 4. This is minus 5 root 3 instead of plus 5 root 3 because of the minus here. But when we square that, we still get 5/9, so the answer comes out to be the same. Solve for x. This is 3j. And the first thing we're going to do is multiply through by 8 to get rid of the fraction. So we don't have any fractional terms. So if we multiply the first term by 8, we get 8x squared. 8x over 2 becomes plus 4x. And 8 times 1/8 becomes minus 1. Now we're going to choose the highest number that here's a denominator is 1, 1, 2, and 8 go into, and the highest number here is 8. By multiplying through by 8, we clear all the fractions, and that makes the problem a lot easier. So now we have this equation. In this case, a is the coefficient of x squared, which is 8. b is the coefficient of x, which is 4, and c is minus 1. If we put that into the quadratic equation, we get minus 4. B is 4. B squared will be 4 squared minus 4. A is 8, and c is minus 1. So here we have 16. Here we have plus 32. So, and the denominator, of course, is 2 times 8 here, so that's 16. So 16 plus 32 is 48. Now, 48 is equal to 16 times 3. So we try to make this, combine this some way into the product of something that is a perfect square if it's available, and it is 16. So 16 times 3, we take the square root of 16, we get 4, and the 3 stays within the root sign. Now at this point, what we can do is factor out 4 from the top and the bottom. That's one thing we can do, in which case we'll get this. Or we can say minus 4 over 16 is 1 over 4, and here the 4 in the 16 goes also 1/4, so we get the root 3. So you can do it either way. Probably the easiest thing is to factor out 4 from here and 4 from here and cancel the 4 from the top and the bottom, and you get this. Now to check this answer, we put it back into the original equation, x squared plus x over 2 minus 8 equals 0. Choose the left side, which is this, and put minus 1 plus root 3 over 4 squared for the x squared term. The x over 2 becomes minus 1 plus root 3 over 2, but we have the 4 on the denominator here, minus 1/8. So when we do this term, the first times the first gives us this, the last times the last gives us this, and the combination of the inner term will be minus root 3, and the outer term will be minus root 3. So we sum those, we get minus 2 root 3. And now what I've just done is transpose these two terms. Instead of writing minus 1 plus root 3, I've written root 3 minus 1. And this is 1/8. So notice that this is over 8 and this is over 8. So what I'm going to multiply the top and the bottom by 2 here, and the top and bottom by 2, so we get a common denominator. So this term is this is this, plus 3 is this. Now this is going to be 2 root 3 minus 2, 2 root 3 minus 2, and this, in order to, I'm going to multiply this by 2, top and bottom by 2, in order to get a common denominator of 16. Now notice what happens here. The 1 and the 3 add up to 4, minus 2 minus 2, 4 minus 4 is 0, and this minus 2 root 3 cancels with 2 root 3, and that gives us 0. So if we do the same thing with the next part, I'm not going to go into it in detail. The only thing that really changes here, if we do the other solution, the minus 1 minus root 3 over 4, we just did the minus 1 plus root 3 over 4. The only thing that changes is this was a minus and it becomes a plus, and this is a plus and becomes a minus. So it sums to 0, and you get the same solution. You can see over here, this was a minus and this is a plus. In the other solution, this becomes a plus and that becomes a minus, but they still sum to 0. So whether you use the minus 1 plus root 3 over 4 or use the minus 1 minus root 3 over 4, they both check out and are acceptable solutions. Now we're asked to solve here. And what we can do, as we did in a previous problem, is to realize, well, if the product of these two is 0. Then we can put one of them equal to 0 right here, solve it, and we can take this one, this quadratic here, the product of two. Take this quadratic here, set it to 0, or we can take the other quadratic, which is here, and set it to 0. So essentially what happens here is we say x squared minus 75 equals 0, x squared equals 75. 75 is 25 times 3. Choose a perfect square root here if you can. Take it outside the bracket, it becomes 5, because the square root of 25 is 5, and we get plus or minus 5 root 3. For the other term, we can't factor this, so what we're going to do is use the quadratic, minus b plus or minus b squared minus 4ac over 2a, and b is 4, minus 4 plus or minus b squared, which is 4b squared, which is 4 squared, minus 4a is c, a is 3, and c is minus 6. So here we have 16 plus 72. 4 times 3 times 6 is 72, and it's plus because you have a minus here and a minus here. So 16 plus 72 equals 88. Now 88 is 4 times 22. So when we take out the 4 from the root sign, we get 2, and the 22 is left here. And now we can factor out 2 from the top and 2 from the bottom, and we get minus 2 plus root 22 over 3. So there are 4 solutions in all, plus or minus 5 root 3, minus 3 plus or minus 22 3 over 3, 4 of these. We get 2 solutions here with a plus and minus, and 2 solutions for this one with a plus and minus. And so now we're going to try 5 root 3. We substitute it into here. 5 times the root of 3 squared. 5 squared is 25. The root of 3 times the root of 3 is 3. 25 times 3 is 75. And we have this 75 here minus 75. So the sum of these two terms is 0. We go and do the same thing for the minus 5 root 3. Well, the only difference is that instead of plus 5 root 3, we have a minus 5 root 3 here. But it's still positive. It still gives us 75. So it's identical, gives us the same. Check works out exactly the same. Now, one of the solutions that we said was minus 2 plus root 22 over 3. We substitute this into the quadratic in the second bracket. And so we have 3. Here's our x term right here. Here's the squared, plus 4, the x term right here, minus 6. So when we work out this squared term, of course the 3 squared here becomes 9. The first times the first is 4. The last times the last is 22. And now the middle term, the inner middle term, is minus 2 times root 22. The outer term is also minus 2 root 22. And when we sum them, we get minus 4 root 22. So here, we're not changing this. And we go down over here. And what we're doing is we're dividing 3 into 9 here and left with 3 on the denominator. Or if you want, 3 over 9 is 1/3, and the 1/3 part is right here. So now we have this over 3 and this over 3. This is not over 3, so we're going to make a common denominator. So these 3 terms here become these 3 terms here. And now 4 times minus 2 is minus 8. And plus 4 times root 22 is plus 4 root 22 minus. and this is 18 because this is 6 over 1, so I can multiply the top and bottom by 3 to get 18 over 3. 18 over 3 gives you the 6, and the minus, of course, is right here. So all we're doing there is getting the common denominator. Now let's take a look at this. 4 plus 22 is 26. 26 minus 18 is 18, and 18 minus 18 is 0. So the first thing I do is handle the numbers separately. 4, 22 plus 22 minus 8 minus 18 sum to 0, and the minus 4 root 22 and the plus 4 root 2 sum to 0. 0 on the numerator, 0 over 3 is 0. So we now know that the right side is 0, and the left side equals the right side. So when we do the minus 2 minus the root 22 over 3, the other solution we substitute into the same equation. The only difference you'll see is right here. Instead of plus 4 root 22 in the previous case, we had minus, and instead of minus, we had plus. So that's the only difference. Only the signs of these two change, both change, but they still sum to 0. So the solution is exactly the same. So see, this is plus and this is minus. Let's just go up and take a look. This is minus and this is plus, but they still sum to 0. Use the discriminant to determine the type of solution. The discriminant is b squared minus 4ac, and in this case we work out b squared minus 4ac. B is minus 10, so we have minus 10 squared minus 4a, which is 11, and c, which is minus 9. So what happens is that this is 100. Minus 10 squared is 100. And minus 4 times 11 is minus 44. Minus 44 times minus 9 is 396. So we get 496. And 496 is equal to 16 times 31. So the square root of 16 is 4, and the exact solution is plus or minus 4 root 31. The 16 comes outside. Now, if you go to what we discussed from page 111, b squared minus 4ac is not equal to 0. And b squared minus 4ac is not equal to a perfect square. This is the case where it has to be a perfect square. 1, 4, 9, 16, 25, 36, 49, etc. This is positive, but it doesn't equal a perfect square. So this is what the solution is going to be. b squared minus 4ac is not negative. Now, how do we know it's not a perfect square? Well, here's the number 496. 22 squared is 484. 23 squared is 529 using your calculator. So it's not neither 22 squared, which is too low, or 23 squared, which is too high. So it's not a perfect square. It's not the perfect square of an integer. So it falls into this category where it's positive, because the value is 496, but it's not a perfect square. So the solution is two irrational solutions, okay? And that means that the solutions, the numbers, when you take the square root of 31 here, will not terminate nor repeat. They just keep on going. So the solution of this is what we call an irrational number, because it doesn't end and it doesn't repeat. So it might be like 5 point, let's say 5, and then a whole series of digits that keep on going and it never ends, and there's no repetition in the number. Okay, show that the equation x cubed minus 8 has only one real solution. what is the real solution? Well, you have to realize that this has the form a cubed minus b cubed, the difference of cubes, and this factors as a minus b, a squared plus, this is always different from this sign, plus the product of a and b plus this term squared. So if this is minus, and this term is positive. If this is plus, this is plus, and this is minus. So we're factoring x cubed minus 2 cubed because 8 is a perfect cube. So if you like, b is 2. So when we factor this, we get x minus 2. Sign here is the same as the sign here. This squared gives us this. Minus 2 squared gives us that. And now this sign here is plus, opposite of this. And if we multiply these two together, we get 2x. So when we factor this, these are the factors. Now, this can equal 0 or that can equal 0 in order for the overall x cubed minus 8 to equal 0. If x minus 2 equals 0, then x is 2. If we set this term, this quadratic, equal to 0, b squared minus 4ac turns out to be a negative number. Let's look at it. b is 2 minus 4, a is 1, the coefficient of x squared, and c is 4. So you have 4 minus 16, and I think this is wrong. This should be minus 12. Excuse me. Let me correct that. This should be minus 12. I'm going to put a 2 here. There we are. Sorry about that. Okay, so 4 minus 16 is minus 12. This is negative, and since the discriminant is negative, there's no possible solution. So there's only one possible solution for this part here. If you substitute 2 into here, 2 minus 2 is 0, and this is 0. When we say that there's no solution, there's no value of x that you can find that will make this equal to 0. With a root sign or without a root sign, there's no integer, there's no irrational solution for this. Okay, so there's only one solution available. Okay, find a quadratic with the given solution. So here we have to come out with a 1 plus root 5 over 2 solution and 1 minus root 5 over 2 solution. So what we're going to do is put x and x here, and then we're going to put the positive solution over here and the negative solution over here. You see, if I set this equal to 0, then x equals 1 plus 5 root 2 as one of the solutions, and x equals 1 minus 5 root 5 over 2 as the other solutions. So the key thing is to go from here to here. Because of the plus and minus, the plus goes here and the minus goes over here. So this is the equation that will give these solutions. Now, to simplify it, just to simplify it, what I've done is I've taken out the minus a half here, put it with the first term in both cases, and then I'm left with minus the minus root 5 over 2 here, minus root 5 over 2 here, because if I take away the bracket from here, if I take away the bracket from here, I have x minus a half, which I combine with this, with the x term, and then I have minus root 5 over 2 here. Because of the minus and the minus, I'm going to have plus 5 root 2. So now this is the difference of squares. This is the same as this. This term is the same as that term. This is minus and this is plus. So when I multiply these two together, it'll be no middle term. It'll just be the first times the first and the last times the last, which gives me this. And the inner and the outer will sum to 0. That'll make it a lot easier. And now if I work on this, the first times the first is x squared. Here I have minus a half x and minus a half x as the inner and outer. They sum to minus x. And minus a quarter times minus a quarter is plus 1/4. And here we have minus 5/4. So when I sum plus a quarter minus 5/4, I get minus 4/4, minus 4 over 4, which is minus 1. So there's the basic equation. That answers this question. Find the quadratic equation with the given solutions. In other words, if I use the quadratic on this, then that'll give us the solution. Now let's check this right here. We're going to substitute 1 plus root 5 over 2, which was one of our solutions, into this. And we're going to put the left side, which is this, substitute the solution which were given in the problem. So this was one of the solutions. Substitute it in, replace the x with this, replace the x with this, minus 1, and then check what the left side equals. So if I multiply this by itself, first times first becomes this, root 5 times root 5 is the inner term and root 5 is the outer term. When I sum them, I get 2 root 5. Everything's positive. And the root of 5 times the root of 5 gives me 5. And 2 times 2 gives me 4. Now, this minus 1 over 2 is this term here. And minus, removing the brackets on this term gives me that. So all I'm doing is removing the brackets here. And I get minus a half minus root 5 over 2, and this is the minus 1 here. So now what I do is I choose a common denominator, and I get 1 plus 2 root 5 over 4, because all these three don't change. Multiply top and bottom by 2, and I get 2 over 4, which is the same as 1 over 2. And here I multiply top and bottom again by 2, and I get 2 root 5 over 4. And minus 1 is minus 4 over 4. Now look what happens here. 1 plus 5 is 6. 6 minus 2 is what? 4. 4 minus 4 is 0. And the plus 2 root 5 and the minus 2 root 5 sum to 0. So everything is 0. So I know that this must be a solution because this sums to 0 and therefore equals the right side is 0. So the left side equals the right side. Now, if you look at this problem and you just go into the other solution, note what happens. This term here becomes minus here. This term here, which is minus here, becomes plus. So the same solution, except that this and this sum to 0 and everything else sums to 0, but the only difference is this changes to a minus and this changes to a plus in the other solution. So we've got two solutions here. Find k such that 1 minus root 2 is a solution of x squared plus kx minus 1 equals 0. So what we're going to do is look at this equation. A is 1, b is the coefficient of x, which is k, and c is minus 1. And we're going to plug it into this equation. So b is k minus k plus or minus b squared, which is k squared, minus 4a, which is 1, and c, which is minus 1. And that should give us the solution 1 minus root 2. So now that we go through the process of simplifying this. This minus k is this minus k, and here we have k squared plus 4 over 2 equals the solution. So this just simplifies to this. And now what we're going to do is multiply through by 2 and transpose the k. So we multiply through by 2, we get this term here. And this becomes, when we multiply through by 2, we get minus 2k over 2. And so what happens is that this becomes plus k, minus k on the left becomes plus k on the right. Okay, so we're multiplying through this term by 2, and we're multiplying this by 2. When we multiply this by 2, we get 2 here. We multiply this by 2, we get this. And here what we've done is minus k over 2. When we multiply it by 2, we get minus 2k over 2, which is minus k, and then we transpose it to the right side, so we get plus k. So what happens is this stays here, this gets multiplied by 2, and this term here gets transposed over here. So what we're doing is multiplying both sides by 2 and transposing the k. Now, we're going to square this term, and we're going to square this term. The only thing is we put these two numbers together here, okay, because they both are numbers, and here is our variable. Now, why do we go from here to here and square it? Because we want to get rid of the square root sign. That complicates everything here as far as k squared is concerned. So when we square this, we get k squared plus 4. We're going to square this whole term right here. So the first squared gives us this. The last gives us this. And the inner and outer will give us 2 times 2 minus 2 root 2. In other words, 2 times this term times the k. So this is the inner and outer in FOIL. This is the first squared, the last, which is the last times the last, which gives us k squared. So this is the first, this is the inner and outer, and this is the last. And now we're going to expand this. First times first is 4. Last times last gives us plus 8. Minus 2 root 2 times minus 2 root 2 gives us minus 4 times 2, which is plus 8. Excuse me. The inner is minus 4 root 2, and the outer is minus 4 root 2, and they sum to minus 8 root 2. So we expanded this. 2 times 2 is 4, and 2 times minus 2 root 2 with the k. I'm sorry, really this, let me go over this again. 2 times 2 is 4. 4 times k is 4k. That's where that comes to. 2 times 2 is 4, and 4 times k is this. Now what we're going to do is 2 times this term here, which gives us minus 4 root 2, and then we're going to put the k here. Let's go over this again. 2 times 2 times the k gives us this. 2 times this times the k gives us this. So the 2 times the 2 here gives us the -4. We still got the root 2, but we have the k there plus the k squared. Now, let's see, we can simplify. You notice I have a k squared term here and a k squared term here. So these two will cancel. So this is this, this is this, this is this, and this is this. So the only difference is the k squared has been knocked out. Now, here, what we're going to do is we've got 4 and 8 is 12. 4 and 8 is 12 minus 8 root 2. This 4k minus 4 root 2k. So the only difference in going from here to here is we sum these two terms. Okay, so now what we're going to do is take the variable terms, leave them on the right here. In this case, we're just going to leave the variable terms on the left, and we're going to transpose these two terms from the left to the right. So 4 minus 12 gives us minus 8, and this minus 8 root 2 gives us plus 8 root 2 over here. All we've done, kept the variable on the right and the numbers on the left, so we've transposed these two terms from the left to the right. 4 minus 12 gives us minus 8, and the plus 8 root 2 gives us minus 8 root 2 on the right gives us plus 8 root 2 on the left. This stays the same and this stays the same. Now I'm going to factor out a 4 from here, and 1 minus root 2k. So I'm just factoring out the 4 from here, and I'm left with 1 times the k gives me the 4k right here. 4 times 1 times k gives me 4k, and 4 times minus 2 times k gives me minus 4 root 2k. I'm just factoring out 4 from these two terms here, and you'll see if I factor out 8 minus 8 from this term over here, I also get 1 minus root 2. So minus 8 times 1 gives me minus 8. Minus 8 times minus root 2 gives me plus 8 root 2. And now I'm going to divide the left side, the right side by 4, 1 minus root 2. So I'm going to divide the right side by this, and I'm going to divide the left side by this, which gives me that. And you can see these two terms cancel, and 4 goes into minus 8 minus 2. So the algebra here is a little tricky. There's no question about it. But it does work. And you have to, probably best thing is to look at this and go through it line by line. Now, to check this, we said k is minus 2, so really what I'm saying is x squared minus 2x minus 1, and I think there's an error here, so I'm going to correct that. Excuse me. This should be minus 1 here. That's right, because it's the same as this. All I'm doing is substituting k equal to 2 there. So that's okay now. Okay, let me go. Okay, so I've substituted k equals minus 2 into this right here. And instead of k, I'm writing minus 2. And obviously this will be the same, minus 1. C is minus 1. So when I work out what x is, it's minus b, which is minus 2. B squared is minus 2 squared, which is 4, minus 4a, which is 1, and c, which is minus 1. And so we come out with minus 2 is plus 2. 4 plus 4 is 8. plus or minus, okay, and this is 2a, and the square root of a becomes 2 root 2. When I factor out 2 from the top and the bottom, or divide 2 by 2, I get this term. I divide 2 into this term, I get that, and I get the solution that I should get. 1 plus root 2 and 1 minus root 2 as the solutions. So 114 number 8, find the greatest value of k such that 2x squared minus 5x plus k equals 0. What we're going to do is we're given a here, b equals minus 5, and c equals k. So we're going to put this into the quadratic equation, though we don't really need to do it, but in some sense, which I'll explain in a minute, we really only need the b squared minus 4ac term. But anyway, let's substitute a equals 2 here, b equals minus 5, and c equals k into this, and we get minus 5 plus minus 5 squared minus 4, a, which is 2, and c, which is k. So what we really need to do is look at this, not the quadratic. We need to look at the discriminant. B squared minus 4ac has to be greater than 0. So if we set this equal to 0, we get minus 5 squared minus 4 times 2k. So I'm just going to take this out. That's a discriminant. And I get 25 minus 8k is greater than or equal to 0. I transpose the 25 to from the left to the right. And now multiply both sides by minus 1. If I multiply both sides by minus 1, I get 8k less than or equal to 25, because when I multiply this by minus 1, the direction of the inequality changes. And if I divide this by 8 and this by 8, k must be less than or equal to 25 over 8. So the maximum value of k is 25 over 8. If it has to be less than or equal to 25 over 8. If it is larger than this, if it's larger than 25 over 8, what happens? The discriminant will be negative. And when the discriminant negative, you can't have any roots. So really what this problem is asking us to do is take the discriminant for c, replace it with k, and then just see what k has to be as a result. And that's what we did. So this completes page 114.